we maintain publicly for some time, but we didn't announce it so far. We'll give you some ideas how you can use it. We'll try to cover, of course, also some of the aspects of how such services are being. So Ontotext as a company exists already 15 years, and since the very beginning, let's say our vision was combining semantic representations of data with text analytics, information extraction, concept extraction, and so on, related to linking content with this rich knowledge graphs, as it's modern to call them nowadays. Applications of this have been done in multiple industries. The publishing industry, for some reasons, is the most active, but also a lot of work has been done in the pharmaceutical industry, in healthcare. There is, of course, interest also in the defense domain. A lot of engineering companies also are looking into this technology, starting with Siemens, the Institute of Engineering and Technology in UK, more recently Bosch, and so on. So it's quite a diverse, let's say, portfolio of organizations. We are known for not only producing a semantic database engine, GraphDB, but actually having semantic enrichment platforms, which are, you can say, one layer above the GraphDB representations and setups. And yeah, on this basis, we have the dynamic semantic publishing platform. That is something resulting in from the work in the publishing area, in the publishing industry for the last 6-7 years. But we have also two vertical solutions in the life science domain. We have some specific developments also in the education domain. So I'll try to start the presentation, and then I'll be glad to hear your questions. I don't know how this is going to work, probably through the QA panel, but if something can, let's say, bring more benefit on the basis of your question regarding what information exactly you want to hear, I'll be glad to actually change the course of the presentation, because I think it will be more fulfilling for both sides. Good. So, Ivo, am I the presenter already, or? I guess so. So I'll start with, you see my screen, I guess? Okay, I mean, nobody is responding, but I guess this is the mute effect. So we'll start with some basic concepts which are related to what we call semantic annotation. And this was a concept that we have developed as an idea in the beginning of Ontotext, as I mentioned, around 2000. The whole idea of actually representing data in structured form, be it with rich schemas that incorporate some semantics about the data and allow different types of automatic inference, is one side of the story. But the other side of the story is related to unstructured or semi-structured information, so pretty much documents, textual messages, and so on. And as you know, just the sheer volume of information presented in such unstructured form is still much bigger than the structured data that we have at our hands. And a lot of the knowledge, a lot of the facts, a lot of the information is there. So having capabilities to get information out of documents and to represent it in a knowledge base or in a structured form, or to link to concepts and instance data, which is in such structured form, is actually key to have some control over your content. It's important not only in the publishing industry, where you actually want to have rich descriptions of your content in order to be able to automatically package new content streams, new content products. But it's also very important in some kind of retrospective archive, let's say librarian style cases in which you actually cannot find your way if you don't have good tagging and good descriptions of the content that you have in your archives. So it is going definitely one level beyond the typical full text search, which is already a commodity, and of course it's much more expensive in terms of time and resources that you need to develop such an application. I mean, no need to hide this. So the example here is quite simple. You've been looking at it for quite a long time. Some of you have probably seen it in some other presentations, but I'm sharing it just because it is key and it is giving you the idea of what is the type of semantic index covering both the schema or the ontology or the domain model, the instance data and the facts, and also the content which is being indexed and represented in a semantic database in such a linked form. Another example from completely different domain. So in this case, showing a text which is covering concepts from the life sciences, specific disease, and also its classification in a set of, let's say, in a classification of diseases, how this is linked to the text itself, how it's linked to the domain model, and so on. So just another point of view to the same semantic annotation modeling. This diagram, I'm not sure you'll be able to see it, so I'll switch the screen so that I'm able to zoom in. But my choice was to start with something that will give you an idea of where such semantic enrichment pipelines actually fit. The focus of the whole webinar is our public tagging service that you'll see in a minute. But actually, it's probably good to see where this fits in a, let's say, more complete solution and in enterprise environment. So I'll try just to switch to the diagram and to be able to show it to you. So on the data layer, of course, in many cases, databases exist in various forms within organizations, covering specific domain entities. So a typical part of the work is actually to transform them so that they're, let's say, syntactically match the RDF representations that we use in such solutions. The task which precedes usually this is what you see on the left-hand side, is usually driven by a so-called information architect in combination with a subject matter expert in many cases. And the task of this group of people is actually to create the schema or the ontology that is describing the data that will be needed. I'll show in a different slide which covers a bit the methodology, why such domain models are created and what actually drives this entire process. In the middle here you see a conceptual representation of GraphDB Enterprise Replication Cluster, which is our triple store. What is more interesting in this case is just another take on the semantic annotation aspect and seeing these layers, which are the schema layer or the domain model layer, the layer with the factual information, the instance data. Yeah, somebody said something, but I didn't catch it. So. And the most interesting part is the actual metadata description of the content. So the annotations, how they are being represented in this hybrid index linking to the instance data and to the content at the same time. Of course, a single graph database is not enough to represent all types of data, so we have connector architecture in which we have adopted different types of information retrieval engines, content stores. Very often we are of course integrating with an external content store, especially in the case where there is a document-centric organization. Let's say this usually either exists or are a part of a bigger solution to not only adapt the semantic enrichment aspects, but actually also to introduce new content stores, new workflows, and so on. So on the level of processing, the most interesting, let's say, key parts are related to the semantic enrichment. In the middle, you see concept extraction cluster that actually takes care of running the different pipelines. Sometimes pipelines which are the same, we just need to run multiple in order to scale. In some cases, these are pipelines which cover either different aspects of the enrichment or they cover different languages, for example. The other APIs are not the subject of this presentation, so I'm not going to focus on them. We have also recommendation personalization engines which are running on top of the results of the concept extraction and so on. And above, just some examples of interaction. So on the level of altering, contextual altering, where as you type, you can get automatic enrichment first with entities of what you're typing in, but actually also to get automatic suggestions of relevant content, of relevant data, and so on, which can improve on one hand side, the quality of the content that you're creating, but also on the other side, it can speed up the process and make the content much richer. Curation user interfaces are related to, on one hand side, correcting the automatic annotations, because as I guess everybody knows, this is not a 100% accurate process. Very good benchmark for this is actually when people are annotating manually, then you see also that it's very hard to reach inter-annotator agreement on some annotation tasks. So this is not a surprise. The other, let's say, benefit of how we use semantic enrichment in the solutions so in our product set first, but also in the solutions we create for clients, is that we hook in the corrections coming from the editors in the curation user interfaces, and actually collecting this as training data, you can say, as a set of examples that have been corrected by the humans, and then actually doing retraining, accumulating retraining corpora, and then doing regular retrainings, which are adapting continuously the extraction quality. On the level of access, let's say presentation user interfaces, and it goes long way beyond search, the typical things that you can expect, like faster search, trend analytics over time based bit on frequency or some other metric. Concept or entity-centric access to the database and so on. So not on the level of individual triples, but more on the level of entire entity profiles. But more interesting aspects are, as I mentioned, profiling of the users and also personalized recommendations on this basis, which are not part of this diagram. And also automatic creation and aggregation of profile pages for specific concepts or directly collections of content, on a specific topic and a specific theme. Yeah. So back to the PowerPoint thing. So this should give you some idea of let's say where concept extraction fits in such a let's say more complete solution scenario. Here I chose just a couple of our clients. I'll talk probably about a bit more than these two that I chose, but the idea here is just to give you some perspective about the diversity of the text analytics tasks that are actually needed. So instead of creating one the text analysis pipeline based on one data set, over these many years, what we are doing is more focused on creating custom text analysis, let's say bespoke text analysis pipelines for the specific domains of our clients. Of course, the one that you're going to access through tag Ontotext.com is a generic one. We'll talk a bit more what it covers and so on. I wanted to give you examples of completely different domains. So with Euromoney, which is a publisher, you can say, which is focused in different types of financial business market information. We had quite a long project that was focused primarily on macroeconomics and macroeconomic research. So a very specific domain where the objectives were not so much finding the individual markets or different types of other financial concepts, but actually trying to capture the view of the macroeconomist on a specific market for a specific period. And to capture also market conditions. And this is a very, very, very specific case of, you can say, compound entity extraction and also relation extraction, which I believe is quite rare as a task. Of course, we have done a lot in the pharmaceutical domain. So AstraZeneca, for example, are completely running their clinical document management on top of our technology, and also with text analytics, with very, very specific domain-specific entities, which are sourced both from internal data sets and also from existing databases that we have integrated and represented as in RDF as a basis for the text analysis. Another example is Financial Times. So Financial Times uses our work in two directions. One direction is the consumer-facing, so ft.com, their website. The first thing that they managed to put in production probably already a year ago was personalization engine that recommends articles based on your user behavior, based on your reading history, based on your interests. That was, again, the profiles were accumulated based on the metadata that we were able to extract automatically from their content. Of course, here the entities are a bit more, let's say, typical. So it's a lot of focus on people, organizations, companies, geopolitical entities. And let's say the more interesting part was big focus on relationships between organizations and people. So different types of merger and acquisition deals, different types of roles of people in organizations, and so on. Mention also the work we are doing with the Institute of Engineering and Technology in UK. So this is something like IEEE in the States. Very, very sophisticated publisher with a very long history. So they're maintaining thesauri and vocabularies for indexing, initially manual indexing since 1969. So you can imagine the depth of their processes. So in our case, they're transforming completely their business. They're basing their annotation processes not on a completely automatic task. It remains semi-automatic just because the value they add with some specific types of indexing or tagging which are very, very hard to replicate. But in general, the tasks there are related to different types of scientific and engineering concepts, which are, again, completely different and are focusing more on the different types of materials, different types of processes, also classifications of the different type of academic research on the basis of whether it's application-focused or theoretical and so on. One major part, let's say, which is a bit different than with in other applications is to be able to automatically suggest new emerging terms in specific scientific domains. So, for example, in the areas of renewable energy or energy storage, for example, new terminology, new materials, new approaches appear all the time. And so far, the updates of their domain model or their ontology have been manual and have been done only once per year, while we are working together to be able to give them automatic suggestions for these. That again can be qualified and corrected by subject matter experts, but this gives you a much faster route to update your models. Yeah? So now maybe I'll tell you just briefly of what is the methodology for building such a text analysis solution, such a semantic enrichment solution as the tagging service that we'll show you in a minute. So first, of course, it's important to understand what exactly you want to extract. And in a typical scenario that is a solution for an enterprise, you actually have to identify what are not only the business requirements, but the resulting functional requirements. On this basis, try to define which are the annotation types that you want to extract, including specific concepts, named entities, but also relationships or classification tasks on the level of the entire document. On this basis, it's very often done in a way by a subject matter expert just to try to do this task manually so that they can define annotation guidelines, which can be used both by the manual curators, but also these are the guidelines for the target solution that we are building, so the target extraction pipeline. Then it's useful to create a gold standard. Very often in, let's say, prototyping mode, this gold standard is omitted if machine learning is not a part of the initial proof of concept. But for the complete solution, it is key to have a gold standard that is used for evaluation in its part and also for training the statistical models in the pipeline. Same time, it is clear that text analysis applications benefit from structured data, entity profiles that are in the target annotation groups. So a completely different data modeling task, let's say, is initiated based on the same type of descriptions and definitions of the entities in focus. So there is not much more to say. I mean, on the higher, let's say, abstract level, this seems to tell it all in terms of how we prepare the let's say, the prerequisites for building a successful annotation pipeline. But of course, when you go in depth regarding resolving inter-annotator agreement conflicts, or deciding on sources and richness and coverage of the data sets that you want to source, there are a lot of details, which sometimes can change, for example, either the quality or the cost quite dramatically. So just another aspect of the, let's say, domain modeling, which is capturing all of this instance data that is supporting the semantic annotation process, is probably just in short with one sentence that is generally good advice to do the domain modeling in a combination between information architect and a subject matter expert. The domain modeling is actually not such a technical process as for example, the ETL, the data integration process, or the text analytics process. So it's more like a conceptual process where one organization should agree on the adequate representation of its domain for its business purposes. Just some examples of what might be the typical parts of one domain model, or you can say one schema or one ontology that is covering a specific solution. So this is an actual example from a publisher, from Press Association. In this case, you can see the asset model, which is describing the content and the different elements of the content, different metadata associated with the content. A separate classification model, which is actually positioning this content or the assets, because it could be also images, videos, and so on, in a specific classification model. Then the tagging model, which is actually the means of indexing or representing the annotations which are linking the assets, the content, to actual concepts in the knowledge base. And on the right-hand side, you see the specific, let's say, for this publisher, it was again primarily people and sports teams and organizations, geopolitical entities, and so on. But it could be any domain model that actually represents adequately the client's domain. Completely different view, but again consisting of content model in the bottom and annotation model. It's conceptual, the conceptual domain model of Euromoney for their macroeconomic division. Just another view of a typical, let's say, selection of entities for, again, in the publishing industry. This was for an association of Dutch newspapers. In this case, we also had, you can say, uniting quasi upper level ontology, in this case Proton, which was mapping to these individual entities, although we were sourcing them from 3-4 different sources like GeoNames, Freebase, Wikipedia, and so on. So how we are building these tagging services, just to get a quick idea about this, and then we're going to show you something. So the initial work is pretty much driven with vocabulary like scanning of the content, and just to capture some initial idea of what is the coverage, what is the accuracy of this recognition. It's completely driven by the labels of the entities which are represented in the triple store. And then on the next level, another major task comes already using the gold standard, which has been manually annotated, and designing machine learning based pipeline. And in this case, there could be a bigger role for the machine learning engineer or a smaller role. We have different methods there for different tasks. We apply different proprietary implementations of algorithms. Some of them we consider to be quite innovative, and we also publish some scientific articles from time to time regarding our innovations in this domain. A typical process, as I mentioned afterwards, is the curation or the automatic manual correction of the automatic results. In this case, it's again an example tool from Press Association. Very often these curation tools are not coming from us. They're an embedded part, an integral part, let's say, of the publishing user interfaces of the. So they're a part which comes after the authoring and before the actual editorial management of the content. So in this case, it is pretty much saying yes or no regarding the correctness of specific entities, choosing between candidates if the data set is too rich and there is high ambiguity. Actually, one of the major tasks that we have to deal with. So just an example. So from the perspective of how this is working in production, then you have the initial manual annotation, which is creating the gold standards, but then you have constant curation. which is the examples of this curation are being collected, and then these examples are used to actually retrain regularly the machine learning pipelines. And just a conceptual view of how one such pipeline looks like. On the left-hand side, you can see the typical components. I didn't mention gates, but this is the framework that we are using as for representing the documents, the actual pipelines, the different processing resources, and so on. It's being developed by the University of Sheffield, and in the past we were the major contributor to this open source framework. Of course, in the moment there is a lot of proprietary components that we are using. The whole thing is wrapped in the concept extraction services that I've shown on the big architectural diagram. So you can say a lot of work has been invested from us to actually introduce the same, let's say the approach that is adopted in Gate to an enterprise level, which was definitely something that we had to do in order to, cover both the requirements for speed, for stability, and so on. So maybe the more interesting parts here, beyond the machine learning, be it for tagging or disambiguation or classification, the more interesting part is that each such pipeline, in our case, results in a, you can say, micrograph that is represented, or a semantic fingerprint of the article, the content that is being annotated, and is represented also in the semantic database. So pretty much it is linking the different entities that are found in the content to the article ID itself, which pretty much gives you the opportunity to query on one hand side the data, on the other side the actual schema or the ontology, and in the same time to query the content. So it's you can say a multi-paradigm index that is being created in this way. Good, so I think we should switch to a demo, but if there are questions in the moment, I would appreciate them. Is there some? It's very quiet, really. I hope you still hear me, though. Good, so the tagging service can be found on tag.ontotext.com. You can use it both as a service incorporated in your POCs. Just give it a try. It is clear that in a real, let's say, application, we expect that this will need to be modified in order to cover a bit a different set of annotations or to specialize the data. I'll explain also what is the data set. I'll just give you one example of, let's say, what can be expected from such a annotation. So you can either copy paste the text or copy paste just a link and then go to the tagging service itself, request an annotation, and then you'll be able to see the different types of entities. So there are, let's say, key phrases which are just statistically, seem statistically relevant to the content, and there are also specific entities. Okay, Stefan is writing to me. He's actually covering your questions. I cannot see if you're asking any, but he said that the URL pasting is working just for English. And not for German content, because in this moment the tagging service is supporting also German, and it's automatically recognizing the content, so you don't need to specify anything if it's another language to pretty much tell you that it cannot recognize it and cannot work on it. So for each entity, as you see here for Cameron, you're getting 2 scores. In some other cases, we can either change these scores or actually come with completely different scoring mechanisms. In this case, the confidence is how confident is the machine learning part of the pipeline sorry about that, I pressed something. How confident is the machine learning part in this specific extraction, and the relevance is how relevant is this entity to the article that is being processed. You can see also some kind of relationships and so on. You can even navigate from here and go to the topic page for this entity. That's good. There is some movement in the chat. So then you can see some of the textual or structured information that we have. Use the knowledge graph that is describing different aspects. It's a subset of the information that we have in the knowledge base. When we have time, we're working on these user interfaces to extend them, but actually, I mean, pretty much our offering is a backend one. So we are using them primarily for demonstration purposes. Different types of quotes which have been recognized in articles by this guy, and so on. So maybe focus now a bit on the types of data sources which are behind. So in this specific pipeline that is public, we are using a combination of DBpedia and Wikidata. There are mappings also to UMBO and to geonames. The types of things that we extract, this is maybe more interesting, is people, locations, organizations, and also different things which are different, let's say, products and as it's called, work, which are, let's say, artifacts of different types, creations of different types, events, and different types of animals and plants. There is, in terms of, let me just show you the stats. So in terms of entities, about 1 million people. There was a better place to see this. Just give me a second. Yeah, so about 1 million people, about 1 million geographic locations, 250,000 of organizations, about 500,000 of different of the pieces of work, as they're called. It's not very intuitive, but we didn't find a better name so far. And about 800 in total of various things which further classified or have, let's say, it's not so easy to choose the proper class for this type of entities, animals, plants, and so on. So I mean, you can use the getting started just to get an idea of how exactly you can annotate and navigate and so on, or you can go directly to the API documentation and you can use it in a way. I mean, what is important here, because you can use also our S4 service. It's not exactly the same pipeline, but you can find other pipelines by us. But the interesting part here is that the tagging service, as it is presented here, the concept extraction service as presented here in tag.ontotext.com, is actually the same shape and the same API, and that is the APIs that we are deploying at our clients. So this might be an, let's say, incentive for you to use it. I can show you probably just because it's just a tagging interface, you can copy paste whatever you want, but I can show you in our other demonstration service, which is capturing some news from the web using absolutely the same concept extraction as you would find on tag Ontotext.com. It's also accessible. You can see a bit more in a bit different interface. You can see the different types of annotations, like for example, relationships capturing that this guy is chief market strategist in a bank, and this bank is located in Atlanta, Georgia, and so on. So quite sophisticated, let's say, levels of extraction. At some point, we might be extending this with different domains. It's quite easy for us to cover different languages, just because we have an automatic way to change pretty much the lexical aspect. And after covering some of the generic, some of the generics which are needed as a baseline for the language itself, then actually on the level of individual concepts, it's quite easy to transform the data sets and actually to start covering it. So what is interesting, yeah, like very, very specific entities like the Dow Jones Industrial Average. You can see here the different mentions from the text. You cannot see really the numbers so much that you are seeing in line, but it's how we choose that the article is about the Federal Reserve and what are the mentions that we choose to show here. It's again based on the same kind of relevance scores that I showed you before. And as we showed, you can further navigate and actually get an idea of how an automatically aggregated topic page could look like. So based completely on the annotations that we are extracting. So from, for example, here we have co-occurrence-based associative links, which are being accumulated without knowing exactly the type of relationship, but based just on occurrence in the same context. So that's pretty much it, I guess. I mean, I would like to hear some questions. And yeah, what should I read questions or?
I think we've got them covered already.
Okay.
To be honest, and if you don't have anything else to add, we can wrap this up. What would you say? Wrap it up?
It's up to you guys, actually. I mean, I don't know how. I mean, we have some.
There's
If Stefan wants to add something, or Valu wants to add something, or if there are more specific questions, because this was quite an overview which actually covers the different aspects. You can use concept extraction APIs for your own POC development, or give it to your developers if you're not a developer. But it's clear that, I mean, changes in the data sets and changes in the training corpora is the way to adapt them to your needs, for which we can help. So, Eva?
Can you mention something about the multilingual approach?
Yeah, maybe Stefan can do it because he's with you now.
Oh, Stefan, it's now to you.
Yeah, thanks, guys. Do you hear me now? Hope so.
Yeah.
A few words about the multilingual approach that we have implemented here. The baseline is that we are able to bootstrap semantic annotation pipelines in different languages based on DBpedia and Wikidata. So we have tried to to get rid of all the language-dependent features, and we are able to train statistical model to disambiguate candidate annotations. And of course, it turns out that language-dependent features help after all, but the model is absolutely language independent. So it should cost us just a couple of weeks to bootstrap such a service in French or in Italian or whatever properly written language, I'd say. Obviously, Arabic and Chinese, Japanese are much different due to the way content is tokenized.
Yeah.
But in this service at the moment, we have demonstrated a pipeline which is extracting concepts in German based on DBPD and Wikidata.
Yeah, so we have covered to some extent Italian for a client. We had experiments with.
Bobby, can you hear me?
Yeah.
Okay. Well, I guess we can wrap that up right now. Thanks both to Bobby and Stefan who joined in at the end. Two things I wanted to draw your attention before we wrap this up. One is some additional reading on dynamic semantic publishing that you can find on our website, but for your convenience, I will forward a link along with a link to the recording and the slides, obviously. And also, if you're interested in applying semantic technology yourself, I strongly encourage you to start with GraphDB free. This is the newest member of the GraphDB family. You can download it quickly and for free. Now I want to thank everybody for attending today and staying with us till the end. Thanks for taking the time on a busy day. Borislav, thank you too for this interesting presentation and for putting up with the few questions we had. A link at the end, a link to the recording that you can share will come out soon. If you have any additional questions, of course, you can forward them to info@ontotext.com. And I think that's it. Have a great holiday, everybody. Bye.